Hi everybody, in this video I'm going to show you something very exciting, and this is Depth API. We're going to show you a demo that runs on the Meta Quest 3. This is a using experimental feature available on the Oculus Samples on Github, and I basically compiled it in Unity so you can run also some changes so you can run on the Quest 3. And basically it was designed to enhance mixed reality. So I'm just quickly going to go over it here. Depth API is a new feature that exposes to application real-time per eye per frame environment depth estimates from the headset point of view. This repository shows how Depth API can be used to implement dynamic occlusions. This technique is essential for rendering believable visual interactions between virtual and physical content in your apps. This enables a more coherent sense of reality for users. Now, for those of you who don't understand what I mean, basically on the Quest 3 you have depth scanning. You have those cameras at the front that can scan your environment, as you can see here. You do it once and then it has kind of a fixed static mesh digital replica of the physical surrounding. The resolution isn't high, you see, it's kind of a construct of triangles that, again, the resolution is not super high. It takes relatively fast to scan, but it's not super fast. The problem with it, again, that you can only have and the problem with this is only updating the mesh when scanning. So you can see here, it's updating because I moved the box, right? If I put it back, you can see there's a bump over there, but now it's going to flatten it out because it's just moved the box. So basically updating things in real time. Of course, having this in real time, of course, it would use more GPU. I can show you more examples. For example, if I open the door, right, now we scan outside, but the part of the door will be now hollow, you see? If I close the door, it still remember what's behind the door, but where the door is, it will now rescan it again. Right? Because it does it dynamically and in real time. Another thing you can see that it doesn't actually scan my body, but again, it captured that texture on the pants. So if I was wearing pants, for example, in this case, it will probably pick up everything and will adjust it. Of course, I don't want that because when I play a game, I won't actually be in the same place that I was before. Now, when defining the room, you have the option again to get the scan, and you also have option to define object. Basically, this is part of the surfaces of the room, which also includes wall. So I can define, for example, a table and other things. I can tag them as well for developers know, for example, this is object is a table. But based on what my understanding, which I checked in Unity, developers can decide to use either the scan surface or the planes, right? They can use them both. Based on my understanding, again, I'm not a developer, but I checked the Unity options there, and it seems like they have two options to choose it from. So again, not 100% sure. But you can see here basically the scan area. I'm using Figmin XR app, so you can see that if I move an object, basically the mesh is already fixed, closed, right? It doesn't change now because it's after the initial room scan. And I can change to planes, and you can see the planes. I scan the table there, and you can see the walls, right? So I can just switch between the two. And this is basically what in Unity you can do, and I think you can just program it to use either the planes or the mesh. No worries, I'm going to get to the great stuff in a moment. So basically, again, the depth scanning the mesh was designed to allow you to occlude and hide virtual objects behind physical content. Now, if there's no occlusion, that's what will happen. Both will just fall on some surface they design, not on the floor, and just continue forever moving on. They're not aware, basically, of any physical object out there. But when we have a mesh and we take the ball and kind of take this box and put the balls, you're going to see what happens. I'm just going to rotate. Now it's actually aware of the mesh. The mesh, by the way, overlay can be removed. I'm going to show you this in a moment. But you can see they're just standing and confined, but the mesh, the room structure, basically the mesh there, the 3D mesh. And if you just bump into something, collide, and be occluded. Basically, there's a holder that I didn't scan. Right, of course, I can just hide it, and you can see now it looks more realistic, of course, because it doesn't highlight the mesh. But of course, the scan wasn't perfect, but again, just for demonstration. And I can change, by the way, to planes, and you can see how it reacts to planes. With planes, you can see when I define the table, it actually just blocks the entire area, so balls don't get underneath the table. But they can jump on top of it and can hide behind it, but they can't get underneath. A limitation of that, of using the planes. So two important things are going to be solved, at least partially, with this technology. Basically, again, your hand can appear, basically there are two separate layers, the video layer and the virtual layer. So basically, most games that you play, you're going to see that when you see your hands, they can always be underneath the virtual content or on top of it, or it depends on what the developer decide. For what I've seen in Unity, there are two options. You can decide that the virtual layer will be on top of the video feed content or behind it. But in most games, it's going to be on top of it. The virtual content will be on top of the video feed. Now, the thing is that we need to solve two things. First, with a moving object that will be updated automatically. And second, that can also segment our hands, so our hands can appear above virtual content. And the depth API, the dynamic occlusion, allows just that. Basically, right now, there's no room scheme here or no planes. You just use dynamic occlusion. So I'm going to give you, of course, examples here, and you can see how it works. Now, this simple app has three modes: no occlusion, soft occlusion, or hard occlusion. Hard occlusion uses less computing resources from the GPU. But have rough edges, kind of jaggy edges. Soft occlusion is more accurate, but of course requires more, put more stress on the GPU. And just so you know, the reason the sign is always on top of my hands because it wasn't assigned this dynamic occlusion thing, so it's not actually being tracked. Now this will happen each frame, and the thing is that, for example, if you decide to play a game now, when you decide to move the table, remember, the initial scan, this is what the game's apps will work with. But again, the table change. So if there's a physical ball with physics on top of the table that sits there, when I move the physical table on the right, to the right, the ball actually won't see any changes. It just is still on top of, basically in the air, which of course this is not something that we want. We want basically a seamless integration between the physical and the virtual, so they both react to each other. So you can see, of course, the yellow ball is virtual, the box is physical, and you can see that if I put it there, this is no occlusion. Well, you can see just through. It doesn't really matter how far or how close you put it, it's still going to appear on the box itself, right? Because two separate layers, right? Now we're going to do something. We're going to turn occlusion on. This is hard occlusion, and you can see that it's hidden now. It's still over there, but it's hidden because I turned hard occlusion on. Right? We're going to see that, but let's just move the box, see if it's actually there. Yes, it is. It's there behind the box. The physical box hides the virtual content behind it. This is due to the depth API. Again, here is just demonstrating the hard occlusion. I'm going to show, of course, the differences between the two in a moment. Let's just move it a bit more. You can see it's very dynamic. I move the box and it hides this yellow ball. Virtual one, of course. You can see that it's not super accurate. First of all, you can see that it does create a segment of my hands, basically my body, that can appear now on top of the virtual content, right? This is hard occlusion. I'm going to turn now to soft occlusion. You can see it's more accurate, but still not perfect, right? You can see it's not perfect. These jagged edges, it's still kind of well, you can see it yourself. Let's just use the hands. Now, the reason for that is very important in apps that actually use your hand with hand tracking only. Now, the way developers solve this is basically either replacing your hand with putting something virtual on top of it. It can be even a semi-transparent glove, for example. It just kind of overlaps your real hand. So this virtual thing will appear on top of the other virtual content that can actually be seen like your hands, because the hand tracking will actually move this cover virtual, let's say virtual glove, the same as you actually move your hand. But still, there are apps that don't use it, and some apps you really want to use your hands and nothing more. It's not like a game that you have an alien hand or something, and maybe you're not going to hold any other object in your hand like a gun, you're just going to focus on the gun. The thing is that we want this feature to be available, again, for both reasons, for body segmentation here, and also for dynamic occlusion. This is again soft occlusion. We're going to put now the cup at the back. The cup is, of course, is virtual. The box is physical. Now you can see my hand in front of the fire animation there. So you can see how it works with animation as well. You can see my hand, and now where the fire is. Now again, let's put more things. Again, I can move the table, I can move, I'm going to show you soon, everything in the room, everything just dynamically adapts and occluded, can't say perfectly, but pretty well. So basically this hopefully will be further improved and will be out of experimental feature, so developers can use it and will still be, you know, convincing, because otherwise developers won't use it because it kind of, I mean, it does improve, of course, immersion, but some developers probably wouldn't like these imperfections. Now, of course, there are more disadvantages for this. For example, if I take something more dynamic like toilet paper and try to wave it in front, you can see that sometimes, again, it does it well, sometimes not. Again, you probably need something with better contrast and textures in order for you to pick it up better. Let's put things behind the door. By the way, it's not the area that is a bit dark, so that's why you see that it suddenly disappears. But again, if you have enough light, it won't be like that. But you can see that I'm just closing it. Something behind the door, and when closing the door, it's hidden. This is without occlusion. This is with hard occlusion. And now with soft occlusion. Sorry for all the mess there, I'm just trying out on many different objects, real objects. For example, another example is if you want to kind of play the guitar. Again, this is a virtual guitar in my real hands, of course, and you can see that you can actually just feel more immersive. Because otherwise, if I use an app where I play guitar in a way like that, it wouldn't work well, it wouldn't display well. The other thing is you can see that something that is smaller, like cables, it doesn't track. Unless I put my hands or something else that have cover a larger area, it just misses it all together at all. It just doesn't occlude it. Right? If you put it together with my hands, it will be, again, because it's my hands and the cables, but the cables alone are not occluded. So this is another limitation. But also keep in mind that it's also dark, black, and probably also something that prevents this from being scanned properly. The same thing, by the way, issues with transparent objects. Right? You can see that the part which is transparent is not occluded. The part that has more contrast and textures there is occluded. So you can see that the transparent area is not. Right? It's another something limitation. Remember that if you do depth scanning as well, if you depth scan and there's something transparent, you won't actually capture the glass, right? You won't mesh it, or if it does in a way not properly because of reflections and stuff of different other objects in the scene. So something to know as well. All right, this is soft occlusion, moving my hand around. So overall, this gave you an idea of things kind of work. This is again a sample from Oculus Samples on GitHub. You can download it yourself on Unity and compile it and try it out yourself. And yeah, really, really cool feature. Hopefully will be improved, because for me, this is a must in mixed reality, especially when using your hands, you know, in hand tracking and your hands in the real world. You don't really want to see them always below the virtual content. And this even in the game's designed to kind of tackle this, I told you, with some maybe cover, maybe some kind of a hand, virtual hand, or maybe just, for example, creating, if there's a game like First Encounters that come with the Quest, they actually created the visual effect not too low, so they won't really you won't actually see your hands when shooting that are actually underneath the holes in the wall. So there are ways to counter it, but basically to enable even more creativity for developers, this needs to work and work well. Until the next video, I hope you find this one useful. If you have any question in the comment section below, feedbacks, other things you think I missed, because I'm not a voice developer, but again, I have some knowledge in programming, so I kind of was able to try it out. If you have other things to add, let us know in the comment section below. Thanks for watching.